All right, so we're going to start off by looking at section 2.2. Okay, we'll finish up what we didn't finish on that last time, and then we'll look at section 2.3. So we're going to start by looking at a problem that's essentially going to get at what we call a break-even point. Okay, kind of figuring out where a company's not making money, but they're not losing money. It's called the break-even point. So the particular company that we're going to look at, they have two types of costs. Okay, they have a fixed cost and they have a variable cost. And basically what those two costs are is a fixed cost is going to be a flat fee. Okay, they have to pay this much money. Maybe it's the fee to rent the building for the month. But the variable costs is going to depend on how much product they make. Right? Because the more products they make, the more resources they use to make those products. Okay? But the rent for the factory doesn't matter if they make 10 products a month or 1,000 products. They still pay the same fee to rent the building for the month. All right, so that's an example. So we'll do something kind of like that. So this company has a fixed cost of $200,000. And we don't know what that is. Maybe it's the cost for the building. Maybe it's the employee's salary at the factory. But whatever it is, it's the fixed cost. And the company has a variable cost of $1.50 per shirt. Okay, so they're making t-shirts, and it costs them $1.50 for every shirt they make. They're going to sell each shirt for $4. All right, so first we'll come up with an equation that represents this. And we're actually going to come up with two equations. We're going to come up with an equation that models the costs for the company. And then we're going to come up with equations that model the revenue. Now, for our purposes, there's going to be a difference between revenue and profit. Okay. Revenue is just the money that the company takes in, not accounting for anything else. It's just how much money did they take in. If you subtract the cost from the revenue, we'll call that the profit. Okay, so cost is money they spend. Revenue is just money they take in. We'll worry about profit after. All right, so let's start with an equation for cost. Okay. Anyone think they can give me an equation that would represent the cost? Yep, Sam?
200,000 plus 150.
All right, so 200,000 plus, and what did you say? And what did you use for a variable? T. Okay. Where T represents, what is T?
T-shirts.
T-shirts. Okay, so T is how many T-shirts they've made. Okay, so there's your cost. And I had put X because I thought we were going to use X, but T is fine. And revenue as a function of T-shirts. Anyone give me a formula for just the revenue, how much money the company takes in? Jay? 4T. So let's graph those and see what they look like. As far as T, what's the minimum number of shirts we could sell, Sam?
1.
Even less.
Zero.
Zero. Might not sell any shirts. The maximum number of shirts we could sell, we don't know. Let's put in 3,000. Okay. Eventually, I kind of hinted at what I'm looking for here. I'm going to try to see where cost and revenue equal each other, and there's a name for that point. So Y is our cost and revenue. Okay, we're doing both on the same axes. Well, either way, we're not going to have negative costs and we're not going to have negative revenue. But Y max, just looking at the cost one, what's the Y-intercept for my cost equation? Dylan?
200,000.
Yeah, it's 200,000, so I've got to set it at least that high. In fact, I'm going to go 250. Okay, now I got to type in my equations. 200,000 plus 1.5, and remember just to use x as the variable this time, and 4x. So I did something wrong on my window. Let me just check. Oh, Lyman, I had those reversed. So 0, 250,000. Right, so let's see what it looks like. Right, so there's our cost, and there's our revenue making up to 3,000 shirts. Are these lines anywhere close to crossing? No, so they need to sell way more than 3,000 shirts. Let's try 30,000 shirts. So there's our costs as we're producing shirts. There's our revenue as we're selling shirts. What's happening to the lines? Oh, Trevor?
They're getting closer.
They're getting closer, and they're going to meet at some point. Let's say we sell 300,000 shirts. And hopefully this will be all right, so now X max I think is okay. What else do I need to adjust? So I can see where these cross. Yeah, Megan? Yeah, let's adjust Y max. Okay, and I'm going to go to, let's try 450,000. Okay, just kind of trial and error to get a good window. And okay, good. I think we got it. So that's not the only answer for the window, but those are values that work. Okay. So the direction said find a complete graph, and we've done that. Okay, I want to see the graph. There's our graph. Okay. Any questions on that? Okay, now something special is happening right there. Can anybody tell me what is happening right at that point? It's where C of x equals R of x. It's where your cost and your revenue are the same. Yep. It's where you break even. It's where you're not making money, you're not losing money. You've reached the break-even point. So it's the point at which cost and revenue are the same. So in terms of what we did, C of t equals R of t. So for a graph, where is this point? Well, we just kind of looked at it. It's where the two lines cross. So for a graph of cost and revenue, where is the break-even point? Where the lines intersect. Right, so now the next example, we're going to use what we just found, and we're going to figure out the number of shirts that the company has to sell to break even. Does everybody have up to where the lines intersect? Right, so the first way I want to do it is algebraically. Okay, so we want to think of that equation. But instead of putting C of t equals R of t, let's actually fill in what C of t is and what R of t is. So Leo, can you remind me again, what was our formula for C of t?
200,000 plus 150x.
So we had 200,000 plus 1.5t. And Shauna, what was my formula for R of t?
It was
4t. Okay, so we solve that. Bless you. Okay, so I brought the 1.5 over to the other side, and then divide 200,000 by 2.5. So in order to break even, the company needs to sell 80,000 shirts. Any questions on doing that algebraically? Okay, how about graphically? I think we've done it before, but does anybody remember the buttons I need to press to do this? Caleb?
Second calc and then intersect.
Second calc, intersect. And then what do I do from there?
You want to select a point on the blue line.
Got it.
A point on the red line.
Okay, I know I'm on the red line somewhere because I can see it's red. And then what about my guess?
It doesn't matter.
It doesn't matter. Right, so that's how you do it graphically. Let's go like this. All right, so if the company sells 80,000 shirts, what's their revenue? Yeah?
Oh, 210.
How much?
210.
Not if they sell 80,000 shirts. Careful. Megan? That's their profit. 320,000 would be their revenue. What's their cost if they sell 80,000 shirts? Leo?
320,000.
It's also 320,000, and their profit at that point would be 0. Yep. Okay. So that's it for that section. That's the only problem we had left that we didn't get to last time. Any questions on that? Okay. So in the homework tonight, there'll be about 3, I think maybe 4 questions from that section, not very much. We're going to focus most of the time on this. All right, so we're going to look at solving equations, specifically linear and quadratic, algebraically. Okay, so we're not going to really do a ton with the graphing calculator from this point on in this section. All right, so first of all, an equation, and I think we might have mentioned this already in chapter 1. It's basically any statement that has an equal sign, and you have an expression on the left and an expression on the right. And I think I had mentioned there's 3 types of equations. Does anybody remember what the 3 types of equations are? Or one of the 3 types? Oh, Tanya, do you remember? What's that? Linear? So we want to think in terms of like even broader. It has to do with like when you solve it. What's one thing that could happen when you solve an equation? Yeah?
Conditional.
A conditional equation, which means you get exactly one solution. What else could you have besides a conditional equation? Yeah, Leo?
Biconditional. 2 solutions.
Well, let's just extend it to infinite solutions. So that would be an identity. So you could have an identity, you could have a conditional equation, or you could have the opposite of an identity, which is no, yeah?
Contradictory.
Yeah, it's a contradiction. Okay, you have no solution. I'm not going to write all those down again, but those are your 3 types of equations. If your equation uses x as a variable or y as a variable, then you can say we have an equation in that variable. So if I asked you, for example, to write an equation in x, that just means I want you to write an equation, use x as your variable. Okay, to solve an equation means to find all values of x that make the equation true. For quadratic equations, how many solutions could we have up to when you solve it? Sam?
2.
You could have up to 2. When we're talking about real numbers, not imaginary. How about linear? How many solutions could you have up to? When you solve a linear equation. Yeah? You have up to 1 solution. Yeah? In fact, you always have 1 solution. Okay, so an identity, well, I guess I am going to write some of them down. That's an equation that's true for all values of the variable, and there's an example of an identity. Because if you did that out, what's on the left is 3x plus 2, what's on the right is also 3x plus 2. So no matter what number you pick for x, positive, negative, fraction, decimal, 0, it always works. Okay, and a conditional equation, that's one that's true for certain values of the variable, okay, like 2x equals 10. That equation could be true if you pick the right value for x. And again, I think you already have those in your notes from chapter 1, so you don't need to write them again unless you want them. Right. And back in Algebra 1, we learned to check an equation. You take your answer, plug it back in, and see if you get a true statement. All right, so here's a cubic. I don't want to solve it. I just want to verify that negative 2 is a solution. Right, so Gracie, how would I check or how would I verify that negative 2 is a solution to that? Yeah, plug it in for x. So we get negative 2 cubed minus negative 2 plus 6. And I put a question mark there because I don't know if it equals 0. That's the hope if it's a solution. Shauna, what's negative 2 cubed? Yep, negative 8. And Dylan, minus 2
It would be plus 2.
becomes a plus 2. And then if I simplify, j and negative 8 plus 2, negative 6. And now I think we can see 0 equals 0. So we ended up with a true statement, which means negative 2 is a solution to that. Does anybody remember how many solutions a cubic could have up to? Yep.
3.
Could have up to 3. Think of it like that. That's a cubic. It all depends on how many times it crosses the x-axis. And cubics can cross 3, 2, or 1. It has to cross at least 1. Because cubics go down forever and up forever, and they're connected. So they're going to cross the axis somewhere. Okay. Unlike parabolas, they don't have to cross the axis. All right, so there's a linear equation. What is the statement in brackets saying? Can someone translate that for me to something that's more English and less math? Leo?
A and B can be any real number except A cannot be 0.
Yeah, that's all it's saying. A and B can be any real number except A can't be 0. Because if A was 0, you would wipe that part out, and then you wouldn't have a linear equation anymore. You would have a constant equal, just a constant. All right, so we'll go through that really quickly, basic kind of Algebra 1 equation, just to make sure I remember how to solve it. So Megan, in that equation, what's the first thing I would have to do?
Distribute the 2x minus 3.
Yep.
Into the x plus 1.
All right, so let's do that. So we're going to get 4x minus 6 equals 3x plus 3.
Plus 3x plus 3.
Yeah. Thank you. So 4x minus 6 plus 3x plus 3. Next thing we would do. About Abby.
You add the 4x and the 3x.
All right, and what does that give me?
7x.
7x. Anything else on the left?
And then you add negative 6 and 3.
So we got negative 6, positive 3, and what do you get with that? Negative 3. Okay, I'm going to, just to try to keep all the numbers positive, I'm going to bring my x's to the left. I'm going to bring my constants to the right. So that's going to give me 2x equals 5. And what do we get for an answer? Megan?
X equals 5 halves.
Perfect. Okay, we're not going to check that one, but if you wanted to, you could plug 2.5 in, or 5 halves, do it out, and hopefully what's on the left matches what's on the right. Okay, any question on solving a linear equation? Okay, by pre-calc, I assume you can definitely distribute, combine like terms, move stuff, linear, all that stuff. Okay, so absolute value equations. So first of all, absolute value is a V shape. Okay, when you graph it, if you were to just graph something basic, that's an absolute value with 2 transformations in it. Does anyone remember what the plus 2 does to a graph? Yep. Yep, it moves it left 2 and the minus 3. Yep.
Moves it down 3.
Down 3. So it's just an absolute value shifted. What did I say? We said left 2, down 3. So it's going to be a V shape with the bottom of the V right there. If you put a negative in front, it flips the V shape over to look more like that. So basically this graph will look something like that. Not exact. But the point is it's going to cross the axis twice. Those are the 2 answers. Okay, so how do we do that algebraically? Well, take your equation and you have to split it into 2 equations, but only after you isolate this absolute value. Okay, so we always want to make sure the absolute value expression is by itself first. All right, so our first equation that we split it into is going to be exactly the same as the original, except you're going to take away the absolute value bars. So first equation, exactly the same as the original, except just take away the absolute value bars. Okay, second equation, it's going to be similar to the first. You're going to take the original, you're going to take away the absolute value bars, but then you have to do one more thing. You have to change the sign of the number on the other side. Or the short way is just to say negate it. Okay, whatever the number is on the other side, change the sign of it. Okay, so we'll go through an example and take an equation, split it, and then solve it. Okay, so an absolute value problem, it's kind of like you're doing 2 problems at the same time. All right, so first thing I'm going to do is look at that and ask, is the absolute value expression by itself on one side? Abby? Yes, it is by itself. Here's an example of something that's not by itself. 10 times the absolute value. So the first thing you want to do is move the 10 to the other side by dividing. Here's another example. 3 plus the absolute value of 2x plus 3. You would minus 3 from both sides first. Okay? So in this problem, absolute value is already by itself. We're going to split it. Yeah?
What if on the left side it had the absolute value and squared? Would that be considered still alone, or would you have to get rid of that?
if we had an absolute value squared. Well then, yeah, that'd be a little tricky, because if we had something like that, right?
Yeah.
So yeah, I would say still get the absolute value by itself first. But what's going to end up happening is you could have up to 4 solutions, because what would, let's see, when you take the square root of each side, you get 2x plus 3 equals 3, and then you get 2x plus 3 equals negative 3, but that's already the opposite number on the other side. Maybe you would only get 2. We can try that after, but oh, I know why you'd only get 2. Because if you think of this as a V shape, right? What happens when you do an absolute value is it takes any negative part and it flips it up. So like that's in the same with squaring. If you square something, it's always going to come out positive. So maybe if we have a second, we can try it after, but I think this part would be flipped up like that. Okay, possibly. So it would still only cross the x-axis 2 times. I'd have to think about it a little more to be careful, but that's just quickly thinking about, I think something like that could happen, but you'd still only have 2 solutions. Yeah, it's a good question. All right, so let's split this up. Okay, anybody give me my first equation that this would split into? Megan? 2x plus 3 equals 5. And my second equation. Sure.
2x plus 3 equals -5.
Right. And if you just think common sense, it doesn't matter what's inside the absolute value as long as it's equal to 5 or negative 5. Because if you take the absolute value of either number I just said, you get 5. So we solve the one on the left. We get x equals 1. And we solve the one on the right. We get x equals negative 4. And sometimes they're a little picky about whether you put the word and or you put the word or between them. I usually just say or, because x could equal 1 or it could equal negative 4, but it can't equal both at the same time. That's the way I think of it. You can't plug in both numbers for x at the same time. Okay, that's not an overly big deal here, but when we get to inequality symbols right here, like a less than, greater than or equal to, then it becomes a big deal, whether it's an and or you put an or. Okay, but for this part, I'm not as worried about that. Okay. Questions on how we solve that one? Okay. So I guess absolute value, it's almost like a special case of linear, where you're looking at 2 lines that make a V shape, but they don't continue on forever to make like an X shape. Okay, they have almost like a vertex right there. Okay, and you solve them both at the same time. All right, this section also looks at mixture problems. So the kind of mixture problem we're going to look at, you've got to set up 2 equations. So you might have something like, let's say you had a solution of 10% alcohol and 15% alcohol. And you wanted to mix something together to make like a rubbing alcohol solution that was 12%. And you want to have 50 liters of it. How much of the 10 and how much of the 15 would you mix together to make what I just said? Okay, that's the kind of problem we're going to look at. So the first equation you set up has to do with the total amount of stuff you want. So when you mix the 2 solutions together, do you want to have 20 gallons, 50 gallons? How much? And then the second equation has to do specifically with the concentrations. Okay, so it's a concentration times an amount. So they'll give you like, maybe it's a 15% concentration in one solution. The only thing you want to remember is to change it to a decimal. Okay? And then they'll give you a concentration for your second liquid you're mixing in. And as I said before, they'll give you a concentration for the total. Like when you mix it together, how strong do you want the solution to be, and how much of the solution do you want? Okay, so equation 1 just represents the total amount of stuff. So for our purposes, just say if you had a 10% solution, the other 90% is water. Okay? The second equation takes out the water part. It's just looking at the stuff you're mixing. Okay? So a shortcut, if you don't want to set up two equations, is you can do substitution in your head. So if you had, like, let's say you were mixing two solutions together to get 10 liters. You have x plus y equals 10. Well, in my head, if x plus y equals 10, then x equals 10 minus y. So anywhere that I use x in the second equation, I can replace it with 10 minus y. Okay, doing the substitution from step 1. Okay, any question on that? We did something like that when we did the investment problem. If you had a total of $20,000 to invest and you put X in one investment, then you must be putting $20,000 minus X in the other investment. It's exactly the same thing. All right, so we have two solutions, a 10% and a 25%. We want to mix them together so that when we're done, we have 15 liters of 12%. How much of each do we mix? Okay, and this problem is going to lend itself to using two variables, but I've already kind of picked the variables if you want to use A for the 10% and B for 25%. Okay, so first of all, can somebody give me an equation representing the total amount of solution? So something with just the 15. We're going to ignore the percentages for now. Well, Leo? Can you give me an equation that represents the total amount of solution we'll have?
Oh, it would just be A plus B equals 50 liters.
Yeah, there's our first one. A plus B equals 50. There's our first equation. And now the second equation is concentration times amount plus concentration times amount equals final concentration times final amount. So J-N, what's our concentration of solution A?
10%.
N is a decimal? 0.1. And how much of that solution are we using? A. Concentration times amount plus, Sam, what's our concentration of the other solution?
0.25.
0.25. And how much of that solution are we using?
B.
B equals, and Juliette, what about the final concentration?
So it would be 15.
The 15 is going to be the total amount, but what's going to be the solution percentage of that final amount?
So it would be
0.12. Yeah. So the final concentration times the final amount. Right, now I'm going to do substitution right away. So let's substitute in for A. What does A equal using the above equation? Sam? It's 15 minus B. And you could have done that part in your head if you wanted to, but if you want to do it, it's two parts, that's fine. plus 2.25b. And now the right-hand side, I can just do that out. 0.12 times 15. 1.2 times 15. Right, so we get 1.8. And now this is like the algebra 1 equation we had earlier with distributive, except you only have to do it in one spot instead of two. Trevor, what's 0.1 times 15? Yep. So we get 1.5 minus, 1.1b. Make sure you distribute to both. Plus 0.25b equals 1.8. Tessa, what's negative 0.1b plus 0.25b? How much?
0.15.
Yeah, 0.15b. And is that a positive or negative? Positive. So positive 0.15b equals 1.8. Okay, and Rebecca, what would I do next?
Subtract 1.5 from the 1.8.
And what would that give me? 0.3. And my last step, divide each side by 0.15. So how many liters of solution B will I use? Yep. 2 liters. And how many liters of solution A will I use? Yep. 13. Because remember, it was a total of 15 liters. So if you mix exactly those amounts, you will get a 15-liter solution that's 12%. That's basically how you set up every mixture problem. You could also do a mixture of 3 things. That gets a little more complicated because now you have a third variable. And you need a third fact. Like you'd have to say something like the ratio of the first chemical to the second chemical to the third chemical is in a ratio of 2 to 3 to 5. So you'd have to have like ratios, and then you'd also need to know the final concentration and the final amount. But you'd have to have an extra fact to do that. And then you'd have a system of 3 equations with 3 variables, which you solved in Algebra 2.
Does it matter which one you substitute for?
Nope. The only thing it would change is which one you find first and second. Yep. All right, so quadratics. So quadratics are of the form ax squared plus bx plus c. And similar to last time with the linear, a, b, and c can be any real number you want.
At this time, all.
All right, so again, a, b, and c can be any real number you want, except a can't be 0 because if it was, then you'd have 0 times x squared. Now you just turn that into a linear equation. All right, so one way to solve a quadratic equation is to factor. Okay, before we look at that, can somebody remind me, what else can you do if you can't factor? Yep.
You can use the quadratic formula.
Quadratic formula. And what's a third way? We looked at it when we discussed the parabolas last week. It's a third method. Most people don't use it as much. Yeah? Okay, you could graph it. So graphically, there's a fourth way. But there is a third way using algebra. And this way is going to be important for something we're going to do today. Anybody remember the third way? Like if you had a parabola that looked like this, and I asked you what the transformations were, you can't have it written this way. You have to rewrite it. And the method you use to rewrite it is what I'm looking for.
Completing the square.
Completing the square. Yep. So you got factoring, which works sometimes. Completing the square, which works all the time. Quadratic formula works all the time. Graphing works all the time. But factoring is pretty fast. if it's a problem that factors. All right, so since I just mentioned factoring is the first way to solve it, this one probably will factor. And what would be my first term in each parenthesis? Leo? X and?
2x.
Okay, so we're going to have 2x and x. You don't have any choices because 2 is prime. There's only one way to get 2. If that was a 12, well, then things just got a lot more complicated. You could try 6 and 2, 4 and 3, 12 and 1. You get a lot more options. But negative 3 is also a prime number, so that's going to limit our options as well. What kind of signs do I need? Plus, plus, minus, minus, or one of each? Sam? Yep, we're going to need a plus minus, and it does matter which one we put where. What order do you want to put them in?
The plus first.
And the minus second? All right. Let's try it. And two numbers that multiply to give me 3. Shauna? 1 and 3. So if we do this out, I think we're close, because we get 2 times negative 3 is negative 6. 1 times x is plus 1. We get a negative 5. We want positive 5. So whenever your number is like that, there's just one thing you need to fix. What do I need to fix?
Flip the signs.
Flip the signs. Now I get 2 times 3 is 6. Negative 1 times x is negative 1 x. And now I get 5x. So any questions on that? And now, what do you do with each factor? Jane?
You set them equal to 0.
Set them equal to 0? Can you tell me what I would get for that one?
You would get 1/2.
1/2. And set the other one equal to 0. Okay, so there's your 2 answers. Okay, so depending how quick you are at factoring, could be faster than the quadratic formula. Depends. All right. So if factoring doesn't work, one method I said you can always use is the quadratic formula. Yeah.
On a test, when we do what we just did, will you ask if you want it quadratic factor or complete square?
Yeah, if I'm specifically asking about quadratics, I'll probably specify a method I'd like to see you try. And then in the future, you can do anything you want. So if it ever doesn't say, you can always do it. But I'm probably going to want to see that you know how to at least do one factoring and one quadratic formula. All right, so quadratic formula. How many people know how to get the quadratic formula? I'm sure most people know it's negative e plus or minus square root, all that stuff. But not just kind of regurgitate it back to me, but how to figure out what that is. Do you know, Leo? No? No? Does anybody know how to get it? Has anybody ever gone through it and they just don't remember how to get it? Or have you probably, I don't know, has anybody ever gone through where it comes from? All right, so it's a formula you use a lot. So I think it is worth going through how to get it. Because it really takes less than 5 minutes and it's a formula you use all the time. If we use a formula a lot and it would take like 40 minutes to figure out where it comes from, probably going to hold off. I'm not going to go through that. But this one's pretty quick. So the first thing you have to do is start off with just a generic quadratic equation. A, B, and C could be any numbers you want. And what's our first step when we complete the square? What do we always do? Very first thing. Anyone remember? Yeah? Yeah, you move the constant to the other side. So we're going to do everything we would do with completing the square. We're just not going to do it with any numbers. Okay, so we're going to put C on the other side. Okay? And now there's something about x squared. Does anyone remember what you have to make sure of with x squared when you're completing the square? Dylan, do you remember?
It would have to be 1x squared, a equals 1.
It has to be, yeah, it has to be of the form 1x squared. So what could I divide everything by to basically turn what's in front of x squared into a 1?
You can divide it by a.
Yeah, we're going to divide everything by a. All right, so now I'm left with x squared plus bx equals negative c over a. All right. Now, I should have left a little bit of space here because now I'm going to complete the square. You might have a little space, but I'm just going to leave a little room to complete the square. So I'm going to add something to both sides. Thank you. All right, so now to complete the square, I do something with the number in front of x. Does anyone remember the two things you have to do? Yeah?
Don't you take half and square it?
Take half and square it. So I'm going to take half and square it. So basically that means I'm going to have b over 2a, that's half, and then square it. So b squared over 4a squared. All right, so I get b squared over 4a squared. And what do I have to add on the right? Yeah, Dave?
The same thing.
Same thing. If you, whatever you put on the left, you also have to make sure you put on the right. And maybe you can kind of start to see some numbers that are in the quadratic formula a little bit. All right. So on the right-hand side, eventually I'm going to add these together, but I'm going to need a common denominator. But now the left-hand side should factor nicely. Okay, this is the point where it now needs to factor into like x plus 6, x plus 6, or y minus 7, y minus 7. Two things that are the same. Does anybody see what the left-hand side would factor into? And this is where you don't want to really be trying to factor this in your head. You want to know, use completing the square, because one of the steps to get to this tells you how it factors. Right? So like if you had, let's just take this one. And I'll just give you something that works out nice. 9. How does that factor? Oh, Jane?
X plus 3 squared.
So this went right there, not the square, just the x. And where did this 3 come from? What does it have to do with up above? Yeah? It's half of the 6. Right? And look at this one. Let's do x squared plus 4x plus 4. Okay. And actually, let me do something a little different because I don't want to have two numbers that are the same. Let's do 8x. That should work. How would that one factor? X plus 4 squared. That comes from there, and that take half of. Okay, so now follow that same pattern to factor this. What's going to be the first thing inside the parentheses? Yeah? X plus, and what's half of that? Yeah?
B over 2A.
B over 2A. So we're doing exactly the same thing you always do with numbers. It's just if you're not really good with quadratic, with completing the square, it's more confusing with letters, but nothing here is different than what we just did right there. All right. And now on the other side, I'm going to add those together, but I need a common denominator. I think I could keep this one the same. But what would I have to multiply the top and the bottom by to make the denominator a match 4a squared? Jane?
4A.
All right, so I'm going to put 4a and a 4a. So on the top, what do I get if I multiply a negative and then a 4a times c? Trevor? What do we get?
For what?
If you multiply what's in the top here.
4AC over 4A2.
So 4ac, anything else that's with that too? We don't want to forget about?
Negative.
The negative. Okay. Any questions on that part? Okay. Anybody starting to see a little bit of the quadratic formula? Some of it? If I were to, I'm going to keep this the same, but instead of writing it as negative 4ac plus b squared, I'm going to write it as b squared minus 4ac. It's the same thing, all over 4a squared. All right, and my goal ultimately is to get this by itself, the x. So how would I get rid of the square? Would be my next step. Yep. I'm going to take the square root, square root, square root. That's gone. So we get x plus b over 2a equals, and the top, we're just going to leave it. Square root of b squared minus 4ac. And what's the square root of 4a squared? 2a. And now the last thing is to bring that term to the other side. And how would we bring that over to the other side? Yeah.
Subtract it.
Subtract it. So that instead of being a plus b over 2a, what would it become?
Negative b over 2a.
Yeah, it would be a negative b. And I can use all the same denominator because these already have the same denominator. So negative b. And really, when we take a square root, we want to make sure we take both the positive and the negative. So I should really add that in right there. So positive or negative, square root of b squared minus 4ac all over 2a. So there's where your quadratic formula comes from. So really, every time you use the quadratic formula, you are completing the square. Because that's what it is. Okay. So any questions on that? All right, so again, it doesn't take super long, but it is a pretty useful formula, and we use it all the time. So that's what I just wrote down. That's your quadratic formula. Okay. That part under the root is the discriminant. And remember, you can use that to determine how many times it crosses the x-axis. Right. In order to use this formula, you want your quadratic equation to be in standard form, which means it is set equal to what number? 0. A is the number in front of x squared, B is in front of x, C is your constant. Again, that's all algebra 1, so hopefully you know that. I don't think the derivation is algebra 1. I don't go through that when I teach it in algebra 1, but in pre-cal we can take a look at it. All right, so let's solve this one. Looking at it, I don't think that that's factorable. So let's set it up to use quadratic formula. Rebecca, what would A be in this case? 2. B, J? 2. Shauna, C?
-1.
-1. And Dylan, can you fill that into the quadratic formula and tell me what I'll have?
It would be -2 plus or minus the square root of -4 minus 4 times 2 times -1 over 2 times 2.
Yep. Perfect. Now, he said 4, and I have a minus, so I'm going to cancel that out right away and make it a plus. And Gracie, what's 4 times 2 times 1? Plus 4? 12. Sam, is that as reduced as it could be?
Yeah. Wait, no, the 2 and the 4. Can you do that?
You can't reduce it by 2 unless you have a 2 everywhere. So that would mean a 2 on the outside of this root, over here, and down in the bottom. But there is something I can do with the square root of 12. Leo?
Square root of 12 can be reduced to 2 square root of 3.
Yes, you can break it up into square root 4 times square root 3. 4 times 3 is 12, and the square root of 4 is 2. And now you can do what Sam just said. You can reduce everything by 2. 2, 1, 1. So the final answer you would see, or I would expect on a test, -1 plus or minus square root 3 over 2. So if you got square root 12, you're not wrong, you just didn't finish simplifying. Okay? So you might lose a point or 2 for not simplifying. Okay, any questions on that? Now, if this was a solution to a word problem, what do you maybe have to be careful about when you think about these answers? Yeah?
That you only use the answer that makes sense for that problem.
Right, using the one that makes sense. So maybe if you're talking about like how many feet something is away from you and this was the answer, negative number probably wouldn't make sense in that case. All right, let's try this one. Okay, this one, since we just did quadratic equation, I'm going to do this one differently. Can somebody give me, I can think of at least 2 main methods, but can somebody give me one way I can solve that on the calculator? And again, I know this section is more about algebra, but I just kind of want to keep reinforcing the calculator, unless someone needs me to do another quadratic formula. Oh, okay. So Megan, what were you going to say?
You can just
All right, how do I do that?
y1 would be 3x minus x squared y2 equal 1.
Okay, and what am I going to be looking for
Where they cross.
where they cross? So I'm going to start with zoom 6. There's my parabola. There's my line at y equals 1. And how do I figure out where they cross? Somebody remind me of what I pressed to do that? Sure. Second calc, intersect. Okay, I'm not going to do both. First curve, second curve. My guess is closer to the left. So there's one solution. Yeah, I guess I can just do the other one. Second calc, intersect, blue, red. Just move your guess. Okay, so those should be your 2 solutions. Now, what's the disadvantage of doing it on a calculator? What can't the calculator tell you that solving it the way I did last time can? Yeah?
An exact answer.
An exact answer. Calculator cannot give you the exact answer. Okay? But it is a good way to double check your answer.
If we were doing it this way on the test, would you, if you didn't specify where would we round it?
I would round it, I'd say usually 2 decimal places is good, so I'd put 0.38, 2.62. And when we say round to 2, it has to be rounded properly, not truncated. Okay? So you don't just go like that and say 2.61. That's wrong. Okay, you got to round it properly, 2.62. All right. Let's finish up with this one. So this is one where it really, you need a picture to kind of visualize it. So what we're doing is we're taking a rectangular piece of material and we're cutting squares out of each corner. So what we're going to do is along the dotted lines, we're going to fold up those sides basically to make a little tray, okay, with sides on it. And the squares we're going to cut out of the corners are 5 inches by 5 inches. So any question on the setup? All right. Overall here, the width of our original piece and length are given there. All right. So the cardboard is folded along the dotted lines to make a box. And they tell us that the length is twice the width. Okay, so that's going to be important. And the volume of the box after we fold it is going to be 2,040 cubic inches. Okay, so what I want to do is figure out the dimensions of the cardboard. Okay, the original piece of cardboard that I used to make this. So find L and W. All right, let's start with this fact. How could I write that as an equation? Yeah?
L equals 2W.
L equals 2W. So we're going to need that. Now the other thing I want to do is somehow use the volume. When I fold this up, this is going to be in the shape of a rectangular prism. What's the volume of a rectangular prism? Yeah? All right, so volume equals length times width times height. The volume I know is 2,040. Now let's find the length. Now remember, it's not the length of the original piece. I'm talking about this. What's the length of that line I just drew? In red. Yeah?
It would be length minus 10.
Yeah, it would be length minus 10. That's the length. What about the width? Leo?
W minus 10.
W minus 10. And what about the height? How deep is this tray going to be? Yeah, it's going to be 5 because that's the part we're folding up. Now, in order to solve this, I need to have all the same variable. So what could I substitute in for? Yeah.
You could put 2 W's instead of L.
Yeah, so let's take L and plug in 2W. So 2W minus 10 w minus 10, and 5. Well, one thing I would do right away is divide each side by 5. Now remember, when you divide by 5, you do it only here. These are not plus and minus signs between the factors. So you only do it in that one spot, and then 2040 divided by 5. Whoops. Is that 408? Thank you. 2w minus 10 and w minus 10. And actually, I'm going to show you another trick. You can even reduce this a little further before we start solving it. What number could I factor out of the 2w minus 10? Yeah. I could factor out a 2. And I would be left with that. And now I can divide by 2. You don't have to do that, but it will make things a little smaller. And that's going to give me 204 equals w minus 5 times w minus 10. Okay, next step, we would FOIL out what's on the right. W times w gives me w squared. W times negative 10. Yep. Minus 5w. Yeah. Negative 15w, and negative 5 times negative 10 is plus 50. But I'm also going to do what with the 204 to get it equal to 0? I'm going to subtract it. Okay, so we get 0 equals w squared minus 15w. 50 minus 204. Somebody have what 50 minus 204 is? My calculator is not cooperating. Yeah, negative, thank you, negative 154. Okay, and just to save us a little time, this does factor. You don't need quadratic formula. Might be hard, a little hard to figure it out, although w is only, coefficient's only a 1, so you might be able to get it. It's w minus 22 and w plus 7. So if you set each factor equal to 0, what would be your two answers you would get? Yeah, Caleb? 22, negative 7. Which answer makes sense for width? Yeah. 22. I think that was inches. So if my width is 22, what's my length? Yeah. 2 times 22, which is 44. Okay. So that kind of combined solving a system of equations with a quadratic. And if you couldn't have factored it, you just use quadratic formula. Okay. Any questions on that? All right. Okay, so the homework, as I said, from the first page we did, just a couple questions, not that much, 35 to 39. And then most of the homework is on solving quadratics and linear equations, either factoring or quadratic formula, or if it says to use the calculator, you could do that too. So the second page is 96, 1 through 4, 9, 11, 13, 16, 19, 24 to 26, 36 to 38, 52 to 54, and 58. Okay, so we'll take a look at that first thing tomorrow.